Hello everyone, welcome to my channel Mantram by Lalita Rao. So children, today we will study about spherical mirrors. So I hope you all are ready to study this. So yes, without further delay, let's study what are spherical mirrors. So what is spherical mirrors? First, let us try to understand. Okay, imagine you have a hollow sphere of glass. Okay, suppose like you have football, cricket ball. In the same manner, instead of that cricket ball or tennis ball, if you have a hollow sphere or glass ball, okay. So this glass ball, when you break it into two parts, suppose this is that ball, and if I break it into two parts, okay. And on this side, I have polished here, and this part, if I polish it here, then this part will be acting as a mirror, right? So if I polish this part, then this part will be acting as a mirror. So in one mirror, outward part is used as a mirror, and on one side, on the other side, inward part is used as a mirror. So such type of mirrors, okay, are known as spherical mirrors. So such type of mirrors, they are known as spherical mirrors. So spherical mirrors, how will you define it? A mirror whose reflecting surface is a part of a hollow sphere of glass. Means here you can see this is that hollow sphere which I was talking about. Okay. So this hollow sphere of, imagine that this is the hollow sphere of glass, and when you polish this outward bulging part, okay, so when you polish this outward bulging part, so this inward part will be used for reflection, or it will be used as a mirror. Yes, so this mirror, when the inward part is used for reflection, it will be called as concave mirror, right? We call it as concave mirror. But, or we, in general term, we call it as spherical mirror. Okay, so this will be known as spherical mirror because it is a part of a hollow sphere of glass. Okay, and it is acting as a mirror. So a mirror which is a part of a hollow sphere of glass and acts as a mirror, so that is known as spherical mirror. Got it? Yes. Now, instead of this outward part, if you polish this inward part, okay, which is towards the center. So this inward part, when you polish, so this part is polished, and this part is used for reflection. Then this is also a spherical mirror, a special type of spherical mirror which is known as convex mirror. Okay, so basically spherical mirrors are of two types. First is concave mirror and then second is convex mirror. Got it? And what is spherical mirror? It is nothing but a mirror whose reflecting surface is a part of a hollow sphere of glass. Okay, fine. Now let's see what is concave mirror. How will you define concave mirror? Now concave mirror can be defined as, it is also a spherical mirror that we know. Yes, a spherical mirror which has reflecting surface towards the center of the sphere. See, if this is a part of a hollow sphere, if this is the part of hollow sphere of glass, so definitely this sphere will have a center. So this center of that hollow sphere, when the reflecting surface, this is reflecting surface, okay, so this reflecting surface is towards the center of the sphere. So when this reflecting surface is towards the center of the sphere, this is the center of the sphere, okay, of the sphere from which this mirror is made. So when reflecting surface is towards the center of the sphere, then such type of mirror is known as concave mirror. And you can see this hard surface is actually polished surface. So the outward bulging part is actually the polished part, and here the inward part which is towards the center of the sphere, that part is reflecting. So a spherical mirror which has reflecting surface towards the center of the sphere of which mirror is a part is known as concave mirror. So concave mirror is nothing but a type of spherical mirror in which the reflecting surface is towards the center. Suppose if this is imaginary sphere, so somewhere here we have center. So it is towards the center. A spherical mirror which has a reflecting surface towards the center of the sphere, it is of which the mirror is a part, it is known as concave mirror. Now on contrary, just opposite to it, we will have convex mirror. So convex mirror, as you can see, it is also a spherical mirror. Fine. That's absolutely fine. Which has reflecting surface away from the center of the sphere. Means its reflecting surface is not towards the center. This is the center, and this part, outward bulging part, is used for reflection. So this is the reflecting surface. So the reflecting surface is away from the center of the sphere, right? So it is not towards the center of the sphere, but it is away from the center of the sphere. And this is hard surface, means this part is polished surface. Okay. So this such type of spherical mirror is known as convex mirror. So I hope this is clear to you. What is convex mirror? So we have seen that spherical mirrors are of two types. Spherical mirrors are of two types. One is concave mirror and other one is convex mirror. Concave mirror in which outward bulging part is polished and inward part is reflecting. It is known as concave mirror. And convex mirror means in which the outward bulging part is used for reflection and inward part is polished. Okay. Here outward part is polished, here inward part is polished. And here the reflecting surface is towards the center of sphere, and here the reflecting surface is away from the center of the sphere. So I hope this is clear to you. So the two types of spherical mirrors. So now let's discuss some of the important terms that are related to this spherical mirror, and we should know these the terms associated with spherical mirrors, right? And very simple, these are very simple. Okay, first is center of curvature. Obviously, as you know, if this is a hollow sphere, this is a ball or any sphere, so every sphere has its center. So in the same way, the center of curvature will be the center of the sphere of which mirror is a part. We know that mirror is a part of some sphere. So the center of that particular sphere is known as center of curvature. Got it? So like if this is the sphere, so the center of this sphere, and from this sphere only when you cut it and make two spherical mirrors out of it. So then this center of the sphere of this sphere is known as center of curvature. So what is center of curvature? Center of curvature is the center of the sphere of which mirror is a part. It is the center of the sphere of which mirror is a part. So this is clear. The first term is center of curvature, and we denote this center of curvature by term C. Okay, by the letter C. Now next, pole. This is also very important term in spherical mirror. Pole of the spherical mirror means it is the center or the midpoint of the spherical mirror. Now don't get confused here. Center in the sense the center of curvature is this center. This is center of curvature, which is denoted by, this is center of curvature which is denoted by the letter C. and pole is this center, which is denoted by the letter P. So this center part of the sphere, or which is also known as the midpoint of the spherical mirror. So this is the spherical mirror, right? This is the mirror. Either it is concave mirror or convex mirror, whatever mirror it is. So this center part of, or the midpoint on this mirror is known as pole. So pole is nothing but, we can also call it as a midpoint of mirror. Okay, got it? Yes. So the midpoint or the center of the spherical mirror is known as pole, and it is denoted by capital P. Now the next one is radius of curvature. Now radius of curvature, again, if you know the center of curvature, this is center of curvature C. So radius is, in a circle, the radius is between the center and the any point on the circle. So in the same way, if you can say like the radius of curvature is the radius of the sphere of which mirror surface is a part. Means it is the radius of the sphere, this sphere's radius. So radius will be from center of curvature to this point. Okay, you can also say P and C, distance between P and C. So distance between P and C is equals to R, right? PC is equals to radius of curvature, and radius of curvature, it is denoted by the letter R. So radius of curvature, it is, this is again center of curvature is an imaginary point. So radius of curvature is also the length. Okay, so the length or the, it is the radius of the spherical part. Okay, this spherical surface of which mirror is a part. Got it? Okay. Now let's move to the next topic, that is principal axis. Now what is principal axis? Principal axis means this line. Have you seen this line, right? The imaginary line that passes through the center of curvature and pole. Here we have pole P, and this is also one point. I'll explain you that point also, focus. We call it as focus. Okay, so the line that passes through the center of curvature and the pole, okay, so that line is known as principal axis. So you can see the line joining the pole and center of curvature is called principal axis of the spherical mirror. Okay, of which mirror? Of the spherical mirror. So this arrow, what do you think about this arrow? This is nothing but an object. Object is always represented by one arrow. Okay. So principal axis is nothing but an imaginary line that passes through the center of curvature and pole. Okay, so this is also known as principal axis, and this is also one such important term associated with spherical mirror. Now aperture, what do you mean by aperture, right? So aperture, very important. Sometimes children get confused in this, so listen to it very carefully. Aperture is nothing but the area of which the mirror area of the mirror which is available for reflecting light. Now this is your mirror. Okay, this is convex mirror because this part shows polished part. So this is polished part. Okay, and here this part is polished part. So this mirror is concave mirror and this is convex mirror. Got it? So this mirror, if you see this AB, part A and B. So the area, line, this part, this area which is available for reflection, where reflection can take place. So this area is known as aperture. Okay, this area is known as aperture. So aperture is the area available for reflection, we can say. area available for reflection, from where reflection can take place. That is known as aperture. So in concave mirror also, it will be from here, right, till here. This area available for reflection is known as aperture. Okay, now the next one. There are some other important points. So these were the terms which we have discussed: pole, center of curvature, radius of curvature, principal axis, and aperture. Now some important points which you need to remember when you are talking about spherical mirror. So as we have studied in case of plane mirror, so the laws of reflection of light, that is angle of incidence. Suppose if you have this plane mirror, so angle of incidence is equal to this is angle I and this is angle R. So angle of incidence is equal to angle of reflection, right? And incident ray, refracted ray and normal, they all lie on the same plane. So these two laws, they all lie on the same plane. So these two laws, they are also hold for spherical mirrors as well. Means the same laws are applicable for that are applicable for plane mirror, they are applicable to spherical mirrors also. Suppose if this is a spherical mirror, okay, and if this is the center of curvature and this is the pole, so if we have a line like this, so if a ray of light is striking the mirror, then it will be reflected back, and angle I and angle R will be equal in this case also. And this will be normal, because if this is a straight line, so this is like a perpendicular, so this will be normal. So this normal ray, incident ray, this is incident ray, and this is reflected ray, right? So this incident ray, reflected ray, and the normal ray, they all lie on the same plane. Okay, yes, so this is first important point. And the second is the normal at the point of incidence of spherical surface is always passes through the center of curvature. What does it means? It means, suppose if you have a spherical mirror, this is the pole, this is center of curvature. So in previous case, we took the incident ray from here. So definitely this normal, as this part is straight, so this normal was here. So if we have incident ray here, okay, so the normal will be this surface will be tangential to the circle, and normal will be the tangent to the circle. Okay, the normal should be perpendicular to this surface. So this surface means like a tangent. So it should be like that. So this normal, wherever you draw, if you take this line, whatever you take, so at every point of incidence, always the normal passes through center of curvature. The normal always passes through center of curvature. It will never happen that the normal to the spherical surface at the point of incidence, it is not passing through, center. It never happens. Always the normal at the point of incidence of a spherical surface mirror always passes through center of curvature. So the normal in case of spherical mirror always passes through center of curvature. Okay, then as we have discussed it before about the aperture, right? So what do you mean by aperture? Aperture is nothing but the area available for reflection, right? So suppose if this is the mirror, so this part and this part, this is the area available for reflection. Okay, so this is straight line distance is known as linear aperture. This is known as linear aperture. the distance between two extreme points on the periphery of the mirror. Two extreme points means end points. So the end point is this one and this one. So the distance between two end points on the periphery of the mirror, is called linear aperture. So this is known as linear aperture. Now it means there is another term, right? There is another term which is not linear aperture. So what is that term? That term is angular aperture. Okay. So angular aperture means what? Let's discuss what is angular aperture. Suppose if this is a spherical mirror, okay, and this is the center of curvature. So this end points making some angle with the center of curvature. Let us say this angle is theta. So here theta is the angular aperture, means the area available for reflection, but in terms of angle. So this angle area is available for reflection. So the angle subtended by the periphery at the center of curvature. This is the periphery endpoints. Okay. So how much angle it is making with the center of curvature? That angle is known as angular aperture. Got it? Right? So today what all things we have studied? Today we have studied about what are spherical mirrors. Spherical mirrors are nothing but it is a part of a hollow sphere of glass of which mirror is a part. Spherical mirrors are of two types. One is concave mirror, other one is convex mirror. So when the outward bulging part is polished and inward part is used for reflection, it is known as concave mirror. And when outward bulging part is used for reflection, it is known as convex mirror. So convex mirror or concave mirror both has center of curvature, and a center of curvature is the center of the hollow sphere from which this mirror is made. So this center of the sphere is known as center of curvature. Then pole is the midpoint of this mirror. Okay, this mirror, pole divides the mirror into two equal parts, right? So the line joining the center of curvature and the pole is known as principal axis. Okay, radius of curvature is the distance between center of curvature and the pole, or we can say radius of the spherical mirror. Okay, radius of the spherical mirror. Then same way for here in case of concave mirror, center of curvature is towards the, we can say towards the mirror, and here the center of curvature is away from the mirror. Okay, and then linear aperture, we have discussed the area which is available for reflection. That area is known as linear aperture. I hope this is clear to you. So yes, in our next video, we'll discuss about the image formation in case of spherical mirrors. But before that, we will also discuss about what are the special rays that we need for image formation in case of spherical mirrors. Okay, and then we'll continue, and then sign conventions, and then we'll continue with the image formation. Okay, so until then, bye bye. Have a nice day. And please don't forget to like, share, and subscribe to my channel to get more and more videos. Thank you so much for your love. Thank you. Bye bye.